Now we're going to talk about systems. This is a new section of Unit 3 that we're starting. We're going to find out what is a system, what are open systems, what are closed systems, and what are universal systems models, along with the proper operations of our systems. What is a system? A system is a group of interrelated components designed collectively to achieve a desired goal. A system is a group of interrelated, so they go together. They're related somehow toward the function of what you want to have done. So they're interrelated components designed collectively, so they're working together to achieve a desired goal. Systems are used in a number of ways in technology, and they appear in many aspects of our daily lives, like the solar systems, political systems, and technological systems. One of the things I heard on the news is the discovery of 7 more planets. We cannot reach those 7 planets. I thought that was interesting. So when they say solar planets, that reminded me of that on the news. Can you imagine 7 more planets, but we don't have the capability to be able to reach those planets?
Well, that kind of made me see what kind of life it has on that planet.
If it has any.
If it has any. So far, Earth is the only place with human life.
Yeah, human life.
Yeah.
But there may be other life that's not quite the same as ours. So for systems, we're going to look at input. What's the process? What's the output? And what's the feedback? That's our example that you're going to look at it. You're putting input in. The data's being processed. You're getting an output. And what is that feedback? So this is an example of an email system. You send the information in. You put it in. You type in your message. The computer and the modem sending something. The people who's getting the sending the messages there. And then you have your materials, which is your computer. Your CPU, your monitor, your keyboard, touch screen, whatever you're dealing with. The process. The process is you're going to be typing the message. You're going to be typing the message. After you type it, you're going to send it to whoever you want to send it to. Say we're sending it to Miguel. The management is the server, the modem. What's going on how it's managed when you send an email to someone. What actually happens. The output is your expected delivery. It's the email delivered that you just sent to Miguel. If it's not, did you send it to the right person? Sometimes emails are crossed. He may be Miguel at yahoo.com and you send it to Miguel at hotmail.com. So, or it may get a reject, not just to the wrong person, but you may get a reject because that email address doesn't exist. Your feedback. The email is answered. Could be he got it. The email's not answered. It could be because it was sent to the wrong person, or he's on vacation. He's not checking his emails right now. Or the return email, you had a return email letting you know that it was not deliverable because the email address wasn't right. Or his email could be full because since you're only allowed so much email, then that could be a problem too. Now, we're going to look at open systems. Now, an open loop system has no feedback path. and it requires human intervention. So see here we had input, process, output. We don't have the feedback, so we've got to go in and do something to find out what happened. It requires human intervention. An example of an open loop system. Use your microwave oven. It requires you to type in how long you want the popcorn to be in there, how long you want your sandwich to cook. Whatever the person is cooking, they're going to have to type in the information. So they're going to put it in, and there's no feedback to say when the food is ready. You get the ding, but you may have to put in more time. That's an open system. A closed system, you'll see now we have input, process, output, but we've got feedback down here. A system that uses feedback from the output to control the input. An example of a closed loop system is the heating system in your home. Now, with your heating system, you're going to need to adjust the thermostat when you want it to be warmer or colder or cooler. You're going to adjust it whether you have air conditioning on or heat. You will also be adjusting the temperature. A universal system model. Every system that exists can be broken down using the universal system model. And remember, we have input, what is the process is going to go through, your output, and your feedback. Now, input. Depending on the process, your input can be resources that go into a technological system like people, you're manufacturing something, the materials that you use, the tools and or machines that are making something, energy, information, capital, which is your money, or your time. Those are your input values. Now, people, they will determine what is going to be needed. What's the solution to the problem? How are you going to use your inputs to determine your outputs? If you're cooking something, what's going to be your inputs to make that cake? The cake, or now you're going to switch to cookies, or you're going to switch to a meal. The information. The person must know how to do what they're doing. They need a knowledge of math and science to design solutions to the problems. Or if you're cooking, you need to know how to sit there and read and make measurements. What are your materials? Are they natural materials that you can use, or are they man-made materials? Such as the flour that is natural, but it has been processed. Machines and or tools are needed to turn raw materials or industrial materials into the final solutions, like your flour. Energy. It allows your work to be carried on out through the system. Remember when we were talking about the energy levels, the electricity, which is required? Your electricity may be your energy in that case. Capital, the money and land needed to create the output. So whatever your store is, whatever your warehouse is, it is included. Now, time needed to design, create, and assess your solution. What is your process? The process is the systematic sequence of actions that combines resources to produce an output. The process are the steps that you go through. You go through, do this, do this, do that. That's your sequence of actions that combines your resources. And it may be written down, It's a process that you go through. You go through the steps. You may need to change the steps, but that's your process. Processes, they can be categorized into several different things. Now, you may have a problem solving process, and that's the one that works through the problem identification to give you your final solution. How are you going to use this process to make what you want to finally do? You revise it, you fix it, problem solving done. Your production, that's a process that involves the creation of the product or the structure. Your creation. Your management, that is how you're going to control and manage the inputs and other processes involved in the system. Because sometimes you will have other processes that feed into your process, and that will help it as well. The output is the end result. Now, if we're looking at the end result, then you can have either a positive or a negative impact. Now, you can get an unexpected desired impact. That could be one. It could be an expected desired. It could be an unexpected desired result. It could be an expected undesired results. So your output, excuse me, is your end result, and it can either have a negative or a positive impact. So it could be unexpected desired, expected desired, unexpected undesired, expected undesired. Now, feedback. Why is feedback important? Feedback is information used to monitor or control a system. So you see your feedback loop. The system is going to take the necessary adjustments during the operation. So the output comes down. It's going into feedback. Feedback's going to say, okay, input, change such and so. Then it repeats the cycle. Repeating the cycle. New and frequent users would need to check out the systems so that they function in a way that they were designed, so that you don't have malfunctions and safety issues. You do not want to have safety issues. You don't want to impact human life or animal life in any way. Now, your stability of a technological system is influenced by all of the components in your system, especially those in your feedback loop. So it's equally important to properly use your system. Now, when you have new people, you need to make sure they're familiar with what's going on. Frequent people, you need to make sure they remember what's going on, because you don't want them to come up and say, oh, done that a million times. Because if you're in a manufacturing location, you want to make sure nobody's cutting themselves. You want to make sure they're not harming themselves. You want to make sure they're not falling. New and frequent users need to operate systems so that they function in the way in which they were designed in order to avoid malfunctions or safety issues. Now, let's think about your cell phone. Have you ever looked at someone and they're using their cell phone and they're not using it properly? Have you all ever seen that? One of the things that I could think of for not using your cell phone properly is having your cell phone on you while you're out there with your gas, pumping gas into your car. Because there could be an electronic surge, just a small surge, from your phone, but you've got gas fumes. Not just gas, you've got fumes. And that's one of the things that could happen. Thank goodness it doesn't happen very frequently because we encourage people not to be on your cell phone while you're pumping gas. Now, any questions because we're getting ready to go over our project. Okay, let's get the lights turned back on.